Hello and welcome everyone. This is Mohammad Inzamam from Saimedha Ecet Coaching Center, Koti, Hyderabad. Saimedha Koti, Hyderabad is providing free of cost YouTube video lectures for previous Ecet examination questions from the effective faculties of Saimedha Koti, Hyderabad. My dear students, in these video lectures every single day for all the branches EC, EEE, Mechanical, Civil and Computers. For all the branches every single day we are updating PYQs, previous Ecet examination questions. So what are you waiting for, guys? Subscribe the channel and press the bell icon to be notified for the further more updates. Daily update చేస్తున్నాం. My dear students, in the era of where people are making everything as a business, Saimedha Koti Hyderabad is giving the coaching for online Ecet 2024-2025, offline Ecet 2024-2025 కి మనం కోచింగ్ అనేది న్యూ అడ్మిషన్ న్యూ బ్యాచెస్ అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈ రోజుల్లో where 10th class admissions are going to be for month, effective faculties లో home tuitions కూడా పర్ మంత్ ఎవరైనా సరే 1000 రూపీస్ కంటే తక్కువ అంటే ఛార్జ్ చేయడం చాలా కష్టం. ఎఫెక్టివ్ ఫ్యాకల్టీస్, రెప్యూటెడ్ ఇన్స్టిట్యూట్స్ లో రెప్యూటెడ్ ఎక్స్పీరియన్స్డ్ ఉన్న ఫ్యాకల్టీ మెంబర్స్ తో మీరు 10th క్లాస్ హోమ్ ట్యూషన్స్ తీసుకోవాలన్నా సరే పర్ మంత్ దే విల్ బి డెఫినెట్లీ ఛార్జింగ్ మినిమం 1000 రూపీస్. అలాంటిది in and around for 1 year you will be getting a payment of around how much? 12,000. For SSC home tuition itself, if you are paying 12,000, guys, Saimedha Koti Hyderabad is providing 1.5 year coaching, 2 years coaching, 3 years coaching. Saimedha Koti Hyderabad lo coaching anedi first year diploma nunchi start అయిపోయినాయి, second year diploma students ki start అయిపోయినాయి, third year diploma students ki start అయిపోయినాయి. 3 years course ఉంటది, 2 years course ఉంటది, 1 year course ఉంటది. అలాంటిది టోటల్ కోర్సెస్ కూడా ఎప్పుడు మన దగ్గర ఫీజు అనేది 10,000 దాటలేదు. అందులో కూడా మళ్ళీ మెరిట్ పెట్టి పర్సెంటేజెస్ వైజ్ కన్సెషన్స్ పెట్టి ఎకనామికల్లీ బ్యాక్వర్డ్ ఎవరైతే ఉంటారో వాళ్ళని ఎంకరేజ్ చేయాలనే ఉద్దేశంతో మినిమం ఫీజెస్ తో మాక్సిమం కన్సెషన్స్ తో సాయిమేధ కోటి హైదరాబాద్ ఈస్ ప్రొవైడింగ్ ఎవ్రీ ఇయర్ కోచింగ్. రిజల్ట్స్ విషయానికి వస్తే యు నో ఇట్ గైస్, ఎవ్రీ సింగిల్ ఇయర్ టాప్ 5 బ్రాంచెస్ లో స్టేట్ ఫస్ట్ ర్యాంక్స్ తో పాటుగా మాక్సిమం ర్యాంక్స్ వాస్ సెక్యూర్డ్ బై సాయిమేధ కోటి హైదరాబాద్ ఓన్లీ. So my dear students, what are you waiting for? Ecet 2024, Ecet 2025, Ecet 2026 coaching has been started in the Saimedha Koti Hyderabad. ఎఫెక్టివ్ కోచింగ్ ఎక్కడైనా ఉంది, మనకు ఎక్స్పర్టైజ్డ్ ఫ్యాకల్టీస్ నుంచి ఎక్కడైనా కోచింగ్ ఉంది, డిజిటల్లీ రికార్డెడ్ వీడియో క్లాసెస్ ఒక సిస్టమాటిక్ ప్యాటర్న్ లో కోచింగ్ వీఆర్ ప్రొవైడింగ్ బోత్ ఆన్లైన్ అండ్ యాజ్ వెల్ యాజ్ ఆఫ్లైన్. సో వాట్ ఆర్ యూ వెయిటింగ్ ఫర్, గైస్? Download the app saimedha.in and press the bell icon to be notified for the every updates. Every single day we are going to be updating in the YouTube channel. Subscribe the channel, press the bell icon to be notified, download the app saimedha.in and scrolling on the mobile numbers ki contact journey and join now in Saimedha Koti Hyderabad. At the end of the video I'll come back one more time for some more information. Till then, guys, watch the video now.
Hello everyone, this is Mohammad Inatullah from the Saimedha Coaching Center, Koti, Hyderabad. So in this video we are going to discuss all the previous Ecet questions of the topic theory of simple bending. Okay, so all the questions whatever we are having in this topic we are going to cover over here. Okay, now let us see the first question. When a simply supported rectangular beam is subjected to transverse downward load, the maximum compressive stress develops at. Okay, what we are having? Maximum compressive stress develops at neutral axis, bottom fiber, top fiber or middle fiber. Okay, we have to remember this part. Now as we are having simply supported beam, let us take this part over here. So if you are taking simply supported beam over here and we are having the load, okay, and we are having the load over here, so means moment, means we have taken moment or else simply supported will be there, no? Simply supported, 2 supports will be there. So if you are taking that part, now what we are doing, let us take this part, how we are getting the answer. So whenever we are having the supports like this, whenever we are having the moments like this, so see this part very carefully, how we are getting the changes, how we are getting the bending over here. So this part we are taking it as a neutral axis. In neutral axis there will be no changes. Neutral axis means what? No stress, no strain. We are not having any changes on the neutral axis. Okay, this is the neutral axis we have taken. But the above the neutral axis it is becoming like this. Okay, this part we have taken, and below neutral axis this part is elongated. Okay, so now this part, this type of bending we are getting in this case, this type of bending we are getting over here. Okay, so this part we have taken. So whatever this part we are having, top fiber, this is neutral axis we have taken, this is neutral axis we are taking over here, neutral axis. This top fiber whatever we are taking, we are getting compression. What we are getting over here? Compression. And this bottom fiber whatever we are taking, what we are getting over here? Tension. Okay, So what is the meaning of this tension and compression? Whenever we are having the tensile load, tension we are having, the body will be what? Elongated. Whenever it is getting shortened, then we are calling it as what? A compression. Okay. So at the top fiber we are getting compression, at the bottom fiber we are getting what? A tension. So over here also let us see this part. The maximum compressive stress develops at neutral axis, no, bottom fiber, no, middle fiber, no, top fiber. So at top fiber we are getting maximum compressive over here. So let us go with the third option. Okay. Now next one. When a load on the free end of the cantilever beam is increased, failure will occur. Okay. Now what we have taken over here, cantilever beam we have taken. So if you are taking cantilever beam over here, when a load on the free end, so as we are having load on this free end we have taken is increased, failure will occur. So for this cantilever beam, actually first let us try to diagrams what we are having, shear force. As we are having for this, the shear force diagram will be looking like a rectangle, okay, and the bending moment diagram will be looking like some triangle like over here. Okay, this part we have taken. So bending moment we have taken at this point. So bending moment is maximum. Bending moment is maximum at this point. We are having maximum bending moment at a fixed end. So what we can write over here, bending moment is maximum at a fixed end. So if bending moment is maximum at fixed end, what will happen? Bending stresses will be maximum. Bending stresses will be maximum at that fixed end only. So what is the formula we are having over here? M by I is equals to sigma by y. So means if you want to find out sigma over here, sigma is equals to m y divided by I. So as we are having maximum bending moment, what we are getting over here? Maximum bending stress, because both are directly proportional. If both are directly proportional over here, whenever the bending moment is increasing, bending stress is also what? Increases. Okay. So bending moment is maximum at fixed end, bending stress is also maximum at fixed end. So where we are getting the failure? Failure also we are getting at what? That end only, fixed end. So failure will occur at a fixed end. Fixed end means second option is correct. Now next part, simple bending equation. Directly we have to remember this formula what we are having. M by I equals to sigma by y equals to E by R. Okay, directly we have to remember over here. So this part we have taken. Sigma means sigma B max. We have to remember this part as sigma B max. Y max. Okay, this is moment of resistance MR, and this is INA, moment of resistance divided by moment of inertia about neutral axis. Bending stress we have taken maximum. Y max we have taken. What is the meaning of Y? Means distance from the neutral axis to the top fiber. Okay, then E, modulus. Okay, modulus of elasticity, Young's modulus we have taken. R means radius of curvature. Okay, so this is a formula we are having for simple bending equation. M by I equals to sigma by y equals to E by R. Sometimes in the place of sigma it will be given F also. Okay, now let us take this part. So M by I equals to E by R is equals to F by y. M by I is equals to R by E, F by y we are having. I by E we are having. R by F, like this, some different options are given. So our correct option is M by I equals to F by y equals to E by R, means the first option is correct. Now next, if E is equals to modulus of elasticity and I is equals to moment of inertia of the beam, then flexural rigidity of the beam is. Okay, now listen carefully. So as we are having the formula, M by I is equals to E by R. Sigma by y also we are having, but we have taken in this case. M by I is equals to E by R. So what we are taking now, M is equals to, if I am sending this I over here, it will become what? EI divided by R. Okay, this part we have taken. Now whatever this EI we are having over here, what we are having, this EI. So this EI we are calling it as what? Flexural rigidity. What we are calling? Flexural rigidity. So directly we have to remember this part. E into I we are calling it as flexural rigidity. Similarly, A into E means we are calling this part as what? Axial rigidity. What we are calling? Axial rigidity. Then similarly what we have taken over here, E into I, we are calling it as a flexural rigidity. Now next what we are taking, G into J. G into J means what we can call torsional rigidity. Okay, this part we have taken over here. Now similarly, what we are having means, suppose we have taken this part over here, this diagram, this curve we have taken. So if you want to find out this theta, this is theta we have taken, this is radius of curvature and this is L. So if you want to find out the length of the arc, over here, so L is equals to, what we have to do, we have to multiply radius and theta, so R into theta, understood. So if you are sending this theta over here, then R is equals to what we are having, L by theta, okay. So over here also in the place of R, if you are substituting L by theta, let us substitute over here. So M is equals to, what we are substituting, M is equals to E into I divided by R, means we are substituting L by theta into theta we have taken, means this theta we are bringing over here. If we are bringing this theta, it will become what, M by theta, it is equals to E into I divided by L, okay. Now whenever we are having flexural rigidity, means what we are having, product of E means what, modulus of elasticity, I means what, moment of inertia. This we are calling it as flexural rigidity. But whenever we are having flexural rigidity, E into I divided by L, then we are calling it as flexural stiffness. What we are calling? Flexural stiffness. Flexural stiffness, which is K, it is equals to M by theta is equals to EI by L, okay, like that we have taken. So directly we can go with what, flexural rigidity means we have to remember EI over here, so first option is correct. Now next part, a beam said to be loaded in pure bending when we are calling, the shear force varies and bending moment is uniform throughout the span, both the shear force and bending moment are uniform throughout the span, the shear force is 0 and bending moment is uniform throughout the span, both the shear force and bending moment are 0 throughout the span, okay. So for this, let us take one simple diagram over here. For this, we are taking overhanging beam, double overhanging beam we have taken, and we are having the loads also, point loads also we are having on the end points, okay. So for this, let us try to draw the diagram directly over here, what is shear force diagram and bending moment diagram. So for shear force diagram, how we are getting, let us see this part. What is shear force diagram we are getting over here? What is shear force diagram and what is bending moment diagram? Okay, let us draw this part. So if you are seeing the shear force diagram, shear force diagram means we are getting this part as, this is positive, then this part we have taken, then this, then we are not having any load over here, this part, then it is bottom, this part, then this part, then below, then next this part, okay. So this is shear force diagram, directly I have drawn over here, this is the shear force diagram for this what we have taken the beam. Now let us try to draw the bending moment diagram. So for bending moment diagram, what we are getting over here, okay. So for bending moment diagram, we are getting this part as this one, then this part, then this part, okay. So this is a bending moment diagram we are having. So what is the meaning of this part means, whenever shear force it is equals to 0 and in this region, suppose we are taking this part as A, B and this is C, D, okay. So in between this CD region, what we are having, shear force is equal to 0. In that region only, whenever shear force is equal to 0, bending moment it is equals to what? Constant. So whenever we are having shear force equals to 0, bending moment is equals to constant, then we are calling it as a pure bending or simple bending, okay, pure bending. Let us see this part. Shear force varies, no. Both the shear force and bending moment are uniform, no. The shear force is 0. The shear force is 0 and the bending moment is uniform throughout the span, okay. So this part is correct. So let us go with option 3, okay, option 3 is correct. Now let us see the next question over here. A part of loaded beam is free from shear and is subjected to only bending moment, then it is said to be in condition of, okay. Already we have discussed this question also. Now what we have taken the example means, suppose we are taking double overhanging beam. So if you are taking double overhanging beam like this we have taken, and we are having the loads also. Okay, this point loads we have taken over here at the ends. Now if you want to draw the shear force diagram and bending moment diagram for this, the shear force diagram, okay, the shear force diagram. So how it will be looking like over here, shear force diagram will be looking like, let us see this part over here. Okay, so this part we have taken. Now we are taking the shear force diagram. So shear force diagram will be looking like this part. This will be shear force diagram, okay, for this double overhanging beam we have taken. Now next, if you are taking bending moment diagram over here, we have taken bending moment diagram. Bending moment diagram means, now for this we are taking this part as, okay, so this is bending moment diagram we have taken. Already we have taken this example also. Now in this part what is happening means, over here shear force it is equals to 0. In this region what we have taken over here, A we have taken, this is B and this is CD. Okay, so in this CD region, whatever this region we are taking, in this CD region what we are getting, shear force it is equals to 0. If shear force equals to 0, then what we are getting, bending moment in this region, bending moment in this region we are getting, bending moment it is equals to constant. Okay, so whenever we are having shear force equals to 0 and bending moment is equals to constant, then we can call it as a simple bending or pure bending. What we are calling, simple bending or pure bending. Let us see this part what we are having. A part of loaded beam is free from shear. Free from shear means what we have taken, shear force it is equals to 0 and it is subjected to only bending moment. Only bending moment we are taking over here, then it is said to be what, a simple bending. Simple bending means option 2 is correct. Now let us go with the last question over here. The quantity E into I, where E is elastic modulus and I is moment of inertia, is called. Already we have discussed this part also. Okay, so whenever we are taking this, what we have taken over here, M by I is equals to E by R. Okay, M by I is equals to E by R. If you are sending this I over there means what will happen, M is equals to EI divided by R. Okay, this part we have taken. So whatever this E into I we are having, E means what we are taking, E means modulus of elasticity, I means what we are having, moment of inertia. So whenever we are having product of modulus of elasticity and moment of inertia, then what we are calling, we are calling this part as flexural. What we are calling, flexural rigidity. Okay, flexural rigidity. Okay, so actually we are having three types of rigidities over here. First, as we are discussing about, if you are having A into E, what we are having, A into E, we are calling it as what, axial rigidity. What we are calling, axial rigidity. Similarly, if you are having E into I, we are calling it as what, flexural rigidity. Okay, now next, if you are taking G into J means we are calling it as what, torsional. We are taking it as a torsional rigidity. Okay, so this topics we are having over here. Now in this part, whenever we are discussing about only E into I means we have to remember flexural rigidity. Now one more point we have discussed over here. Suppose if you are taking this part, now R we are having now. So if you have taken this radius of curvature and this part is theta and this is L. If you want to find out the length of this arc, so what we can write, L is equals to R into theta. So what is R value we are getting over here? R is equals to L by theta. Okay, so in the place of R, what we can write, L by theta we can write. So if you are writing this one, M is equals to E into I divided by in the place of R what we can write, L by theta. So we have taken L divided by theta. Divided by theta means again we have to write in the numerator itself. Okay, theta we have taken. Now if you are sending this theta over here to the other side, now it will become M divided by theta, it is equals to E into I divided by L. Okay, so this part we have taken. Now next, M by theta. Now what we are taking, whenever we are having flexural rigidity divided by length, divided by what we are having, length, then we are calling it as a flexural stiffness. What we are calling, flexural stiffness. So over here also we are taking this part as flexural stiffness, we are denoting by K. K it is equals to, either we can write M divided by theta or else we can write this part as E into I divided by L. Okay, so we are calling this part as what? Flexural stiffness. Okay, so actual answer should be what? Means as it is given E into I is given, means it should be flexural rigidity. But in the options, the flexural rigidity is not mentioned clearly over here. Then we can relate with this what as a flexural stiffness. Flexural stiffness means option 4 is correct. Okay. So with this we have completed all the previous Ecet questions of the topic theory of simple bending. Thank you very much.
So thank you very much guys for watching this video till the end. Definitely this video has been improvised your subject knowledge and definitely given you an idea about how the previous Ecet examination question is getting up here. Again one more time guys, ee video ni meeru nachite kachithanga like cheyandi, share cheyandi, subscribe cheyandi and press the bell icon to be notified for the further more updates guys. Admissions అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈసెట్ 2024, ఈసెట్ 2025, ఈసెట్ 2026 ఫస్ట్ ఇయర్ వాళ్ళకి, సెకండ్ ఇయర్ వాళ్ళకి, థర్డ్ ఇయర్ వాళ్ళకి ఆల్రెడీ ఈసెట్ కోచింగ్ అనేది ఆన్లైన్ కోచింగ్ అండ్ ఆఫ్లైన్ కోచింగ్ new batches is going to be started guys. So my dear students, what are you waiting for? Download the app saimedha.in. మీకు ఏ డౌట్స్ ఉన్నా సరే మన స్క్రోలింగ్ లో ఉన్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి. Join now in Saimedha Koti, Hyderabad. Thank you very much. This is Mohammad Inzamam signing off.